right, I'm going to go ahead and get started since it's 10 o'clock and we do have a long section to do today. A lot of it's calculator work, but I am going to show you both ways on how to do things. What we're going to talk about today is called logarithmic functions. And I want to compare what logarithmic functions are compared to what exponential functions are, which is what we did last week. Okay, they're kind of like they're opposites of each other. Okay, the exponential functions that we did last week, remember what they looked like when we did them on a graph? What did they do? They came along the y-axis for a little while. Then they crossed through the they came along the x-axis, crossed through the y-axis, actually at +1, and then they shot up that way, right? That's what we said, they grew exponentially. That's what an exponential function looks like on your graph. It has some characteristics that we need to talk about. It crosses through the y-axis at +1. There is no x-intercept. It doesn't ever cross the x-axis, and that is because there's a horizontal asymptote on the x-axis. So if you'll notice, this right here just constantly gets itty closer to the x-axis, but it doesn't ever touch it or cross it. Now, a logarithmic function has an x-intercept at 1 instead of a y-intercept. So let's think about where that is. So its x-intercept is at 1, so it's going to cross through the x-axis right here. There is no y-intercept. It's not going to cross the y-axis because there's a vertical asymptote on the y-axis. It comes straight up the y, then it crosses through the x-axis at +1, and then it shoots this way. So that's what your logarithmic function looks like on a graph. So the reason, let's look at what they would look like together on a graph. These two functions, the exponential and the logarithmic function, are what's called inverses of each other. They're kind of opposites, right? This red one would be what we talked about last week. That's what an exponential function looks like on the graph. This green one is what we're going to talk about today. That's what a logarithmic function looks like on the graph. They are symmetrical across this black line right here. This line, the equation of that line is y equals x. So if I folded this sheet of paper on this black line, they would lie on top of each other. Okay, so those are just some standard characteristics of comparing exponential and logarithmic functions. All right, now we're going to talk more today about what logarithmic functions look like and what they mean. The first 3 problems are just some multiple choice graphs. And if you'll notice on every single one of your multiple choice, if you just know what a logarithmic function looks like on a graph, then you'll be able to pick out the right answer. Like on number 1, it says y equals log base 7 of x. And I want you to pick out the graph. First of all, you can go to your y equals, right? We do have graphing calculators. So if I go to my y equals and clear it out, here's where your log, how do you make that little base where the 7's going to go come up? So before I type in log, you would actually go to the math button and then scroll down past the numbers to A. So see where it says log base? So you'll hit enter there. So see, it gave you a place to type in your base number and the x. So you're going to do log, put your 7 down there in the base number. And then in the parentheses is where you will put your x. And then graph it. So it'll make that logarithmic shape. So see how the graph comes straight up the y-axis, doesn't touch it. The y-axis actually has a vertical asymptote on it. It doesn't touch it. It crosses through the x-axis at 1, and then it shoots that way. So when you're looking at your multiple choice, the only one that has that logarithmic shape is B, right? A, C, and D all actually look like exponential functions, with the D just being reflected across the y-axis. So look at number 2. It just says y equals, right? That's what f of x is y. Y equals log x. So I don't even need my base log base button. So you can also type in, if your log doesn't have a base, first of all, that would be understood to be base 10. We'll talk about that in a little bit. But if you just want to type in log x, there's actually a log button. So if you don't need log base and you just need log, you can hit the log button and then x. And then graph it. Oops, graph it. So again, it's that standard logarithmic shape, which again would be B, right, on your multiple choice. The only one that has that shape is that one. Now, number 3 is y equals what's called ln x. ln is the natural log, and it means the same thing as log base e. And again, there is an ln button on your calculator. So just hit the ln button with the x and graph it. Again, same shape, still a logarithmic function. And the only one that has that log shape again, this time is A. Now let's talk about what is a logarithm. Okay, a logarithm, the easiest way to explain it is kind of like it's a missing exponent. What number is an exponent raised to find its logarithm? We're going to think of it like that. So I will show you how to do it in your calculator and how to understand what it means when you're finding a logarithm. So number 4 says log base 2 of 4, and it wants to find the logarithm. So you're kind of like finding a missing exponent. I'm going to change this into an exponential equation by just saying, you know what, I want to find what this equals. What does log base 2 of 4 equal? So there's my unknown. Log base 2 of 4 equals what? So now that I've set this up as an equation, I can solve it. The way that you turn this into an exponent, this is your base. That's your exponent. 2 to what power is equal to 4? So I'm trying to find what number would I raise 2 to make it equal 4. Well, what does this need to be? For this side to equal this side. For both sides to be 4, I would need this to be what? 2 squared, right? Equals 4. So what is the missing or unknown exponent? 2. So your logarithm would be 2. So that's what a logarithm is. It's kind of like an unknown exponent. What would you have to raise this base to turn it into a 4? Well, I would have to raise that 2 to the second power to turn it into 4. Same thing on number 3. Log base 3 of 27. Again, what is the logarithm? What does this equal? What do you need to raise 3 to to turn it into 27. So let's see, 3 to what power equals 27? 3 to what power equals 27? Looking for the missing exponent. Let's see, 3 to the first power is 3. 3 squared is 9. What is 3 to the third power? 3 times 3 times 3, which is 27. So to make both of these sides equal 27, I would need 3 to the third power to equal 27. So what is the logarithm? Or in other words, what is your missing exponent? It is 3. Can I do this in my calculators? Yes. Remember where your log base button is, which means go to your math, and again, down to A, go past all the numbers. There's your log base. Hit enter. You can type in everything you need to type in. What do I need to type in the little base on that one? A 3. Hit your right arrow to get out. And then your 27. So log base 3 of 27 equals what? 3. So the log base button function in your math will do that for you. Look at number 6. Log base 10 of 10. Think about this. What do you need to raise 10 to turn it into 10? 10 to what power is 10? If I turn it into an exponential equation, I'd say 10 to what power is equal to 10. So what do you have to raise 10 to make it 10? It already is 10. What exponent do I need to make that x be to not change it? 10 to the first power equals 10. So your missing exponent is that 1. Okay, before we get into number 7, let's remind ourselves, this was some, if you took transitional algebra, you should have talked a little bit about negative exponents and what occurs when you have a negative exponent. So let's remind ourselves. What a negative exponent does. If I wanted to rewrite this without using a negative exponent, because we don't like to see negative exponents, we like our exponents to be positive. So what the negative exponent says to do is flip your base. Well, if your base is a whole number and I'm going to find its reciprocal or flip it, I need to see its denominator, right? I got to have a top and a bottom in order to flip. So let's see, if I flip my base from 3 over 1 to 1 over 3, that turns my exponent into positive 2, which is the same thing as saying 1 over 3 squared, which is 9. So 3 to the negative 2 power is actually 1/9. So let's keep that in mind if we're finding something where the base turns into a fraction. What turns it into a fraction is having a negative exponent. So let's look at number 7 now. Log base 2 of 1/4. So what would I raise 2 to turn it into 1/4? Well, if I'm going to turn this base into something smaller or a fraction, I'm going to have a negative exponent to do that. So let's think, if I turn this into an exponent, I have 2 to what power equals 1/4? Well, let's see. If I would, how do I turn this side into 1/4? I'd have to flip my base. And then what would I have to raise that 2 to make it be a 4? 2 squared. So what's going to make this happen? If this exponent is 2 to the negative 2 is going to equal 1/4. So your missing exponent right there would be negative 2. Can you put that in your calculator because you're just unsure about that? Sure. Go to your log base, math, down to log base. Log base 2. Right arrow to get out. I type in 1/4, right? Log base 2 of 1/4, so just 1 divided by 4. Oh. Got too many parentheses. Math. Sorry, I typed in too much stuff. Log base 2, and then 1/4. There's your negative 2, right? To turn that into a fraction, you would have had to have a negative exponent. All right, let's look at number 8. It says find the value of the logarithm. You have ln of 1/e. When we're talking about ln, it's called the natural log, and it's the same thing as saying log base e. ln is the same thing as saying log base e. Can you type this in your calculator? Absolutely. Let me show you where that would be. So let's see. ln has its own button on the calculator right below log. So in this parentheses, what do I need to put? I need to put 1/e. So let's see. 1 divided by, now you'll notice on your division button, it has the math e right there. So what do I need to do to get, since it's blue, I need to hit my second button first and then my division button to get that e, and then close it. And what's it going to tell you? -1. Why did that come out to be -1? Let's see. I'm going to turn this ln, instead of calling it ln, I'm going to call it log base e and see what that looks like. So what would you have to raise e to make it 1/e? I would have to raise, so again, if I turn this into an equation that's an exponent, I'd have e to what power equals 1/e. Well, what did I do from this side to this side? It looks like I just need to do what? Flip that e to make it 1/e. So that's why that exponent needs to be negative, first of all, because I'm going to flip it. And it only needs to be -1 because after I flip it, the e just needs to be to the first power, right? I don't have e squared or anything down here. So all I need is to flip that e, which means this right here just needs to be -1. All right, let's look at number 9. Log 10. Again, there is a log button on your calculator, so the simplest thing to do, again, I don't even need log base. If you don't need log base, you just need log. Just hit log, and then again, just type in your 10 and hit enter, and look, it gives you a 1. That is because if you have a logarithm that doesn't show a base, your base is automatically 10. So no base is automatically 10. So this really says log base 10 of 10. which means what? What power would you have to raise 10 to make it 10? Well, what does this x need to be? 10 to what power is 10? I don't even need to change it. That's why I need to do 10 to the first power equals 10. So that's why your logarithm was 1. All right, let's look at number 10. Log base 5 of 5 squared. Again, this right here is easier than going to your math log base, because what am I trying to find? What do I need to raise 5 to turn it to what? 5 squared. Well, for both of those sides to be equal, what does this x need to be? For 5 to the what power is going to have to be the same thing as 5 squared. Well, I just need to turn that x into a 2, right? 5 squared equals 5 squared. So that logarithm was just 2. The missing exponent was a 2. Okay, now, when I did negative exponents, what happened? That flipped my base. That's what turned them into fractions, right? Or numbers smaller. By flipping that base. What happens? What turns something into a radical? Again, this is a transitional algebra topic, but I want to go over it a little bit before we get into these kind of logarithms. If you have a radical, for instance, the cube root of x, and I wanted to write that as an exponent, if you're going from a radical to an exponent, your exponent's going to be a fraction. Which means this is going to be, whatever is in here is going to be your base. Your exponent is going to be a fraction. So if my base is x, the numerator of your fraction will be a 1. The denominator of your fraction will be whatever, this is called the index, the number that's in the little root house. So the cube root of x is the same thing as x to the 1/3 power. So again, if you did take transitional algebra, this was a topic that would have been covered. But I just didn't want to throw it at you without re-going over that. Again, if you are a radical, it is because you came from an exponent that was a fraction. So, now looking at number 11, it says log base 4 of the 6th root of 4. So let's think about this. What am I going to have to raise this 4 to? 4 to what power is going to turn it into the 6th root of 4? So remember, if you are a radical, it's because your exponent is a fraction. So what do I need to raise this 4 to make it the 6th root of 4? Remember, this exponent now is going to be a fraction. This number is your denominator, and then your numerator is 1. So 4 to the 1/6 power is equal to the 6th root of 4. So your logarithm, or in other words, your missing exponent is that 1/6. Now, if you were to type that in your calculator, it's kind of complicated. So I'm going to type in the original problem and do it in my math log base function. So I would hit, because I need to go to log base, right? So I would hit the math button. Down to log base, so down past the numbers, down to A. So my base is 4, so that's not complicated. Now, what do I need to put inside these parentheses? I need to put the 6th root of 4. So if you're typing a number that's a root other than the square root has its own little button on the calculator. But other roots, if I need to put that little 6 in that little house right there, you're actually going to hit the 6 first, which is going to look funny. So hit the 6 first, then hit your math button, and then look at number 5. See how it has that little X up in the radical? It's going to put the 6 there. You have to type in what number you're going to put in this little X spot first. So since I want 6th root, I hit the 6 first and then down to number 5. And when I hit enter, you'll see how it puts the 6 up there in the radical or the index. And then the 4 right there. And hit enter. It's going to give you a decimal. Your paper or your homework's going to say type it in as a fraction. So how do we type in decimals as fraction? Again, if you want to turn your decimal to a fraction, just math. Turn my answer to a fraction, enter, enter. So there's your 1/6. All right, number 12. Let's see, log with no base. We know what that means now. Of 10 to the -6. What does no base mean? It automatically is. It's log base 10. You can type that in your calculator. But again, what would I have to raise 10 to make it be 10 to the -6? What do you need this x to be to make both sides of this equal? Well, if that's 10 to the -6, I need that to be 10 to the -6. So -6 is that missing exponent. So let's see, what does this say? What do I need to raise 625 to turn it into 5? So if I'm going to turn 625 into 5, I'm going to have to take some root of 625 to turn it into a 5, right? I don't need this to be a whole number because even 625 to the first power going to be what? 625. That's way too big. So I'm going to need this to be I'm going to take some kind of root, right? So let's see. I need to turn this into a radical to take some kind of root of 625 to turn it into 5. Again, you can put that in your calculator. Hit log base, or yeah, go to math, down to log base. Hit enter. Your base is 625. Your 5 goes in the parentheses. Gives me a fraction. Math. Enter your fraction to see 1/4. 1/4 is your missing exponent. So 625. To the 1/4 power equals 5, which is the same exact thing as saying the 4th root of 625. Now, there may be some people, and I think there probably are, that don't have that function in their math button. You can still do this in your calculator. I think if you don't have an 84 plus, maybe if you're using an 83 or just an 84 without the plus, it may not have that log base function in your math button. You can use another thing. You can do log of this number. So you should have a log button if you have a graphing calculator, even if you don't have the log base in your math function. You still have this log button. So do log of that top number, which is 5, divided by, again, log, and then do your base number, which is 625. And hit enter. It gives you the same thing, that 0.25 that I need to change to a fraction. So still 1/4. So again, if you don't have under the math function that log base that we've been using, you can always you can type this into your calculator. Log of this number divided by log of this number. It'll give you the same thing. All right, number 14. All right, another topic, again, that is from transitional, is raising something to the 0 power. Anytime you have something and you raise it to the 0 power, it is equal to 1. Doesn't matter what it is. Anything raised to the 0 power is equal to 1. So let's think about that. Going into number 14, it says log base 11 of 1. So in other words, what do you need to raise this 11 to make it equal 1? Well, what exponent turns everything into 1? 0 does. So 11 to the 0 power is 1. All right, number 15, ln of e to the 3rd. I can use my calculator on this. You hit your ln button. I'm going to do it both ways. Let me clear it out. There's your ln button. Now, earlier when I did e, when I was typing in 1 over e on a problem earlier, I didn't want my e to have an exponent, right? So that's why I hit the second and then that e. This e, I need to have an exponent. So this function, if you look above the ln, where's that? Here it is. See that e to the x? That's what I want. So I'll hit my second ln, which will give me e with an exponent, which I'll type in 3. And I'll go to the right and do my closed parentheses. And look what it gives me. It gives me 3. Why is that logarithm 3? What is equal to ln? What does that mean? That is the same thing as log base e. That's what ln means. So if I'm finding log base e of e to the 3rd, what is that saying? E to what power is equal to this? E to the 3rd. Well, e to the 3rd is equal to e to the 3rd. So that's why that x is a 3. Number 16, ln square root of e. So again, I can type that in my calculator, ln. Now, I do have a square root. It's second and then x squared, right? That's where I get my square root. So second square root e. Does my e need an exponent underneath that radical? It doesn't. So I'm going to hit the second and then the division button, right? That's what gives me a plain e with no exponent. and then close. Ooh. Oh, I got too many. Oh, well, it worked anyway. So 0.5, which is what as a fraction? Math, enter that to get 1/2. Why did that end up being 1/2? What is ln? What's log? Base e, square root of e. So e to what power is equal to the square root of e? So remember, how do you turn something into a radical? Its exponent has to be a fraction. And what exponent is equal to the square root? E to the 1/2 power would be equal to the square root of e. So that's why that missing exponent was a 1/2. Now, starting with number 17, we're going to go backwards, kind of. It's going to give us an exponential equation, and we're going to turn it into a logarithmic equation. So let's see. It says 10 to the 6th equals 1 million. 10 to the 6th power equals 1 million. And it wants me to turn this into a logarithmic equation. The way you're going to start off is the base of your exponent is the same thing as the base of your log, right? They both even use the same word to describe them. The base is this number. You raise your base to an exponent. This is the same base of my logarithm. So you're going to type in log base 10. Now remember, you're going to say 10 to what power equals this number. So let's see, I'm going to make an equation. And remember how we were going the other way. We would say 10 to this power is equal to this number. So where do the 6 and the 1 million need to go? I need 10 to be raised to this power to equal that number. So 10 needs to be raised to the 6th power to equal 1 million. So log base 10 of 1 million equals 6. So the easiest way to think about it is to type in log. Your base is the same thing as the base of the exponential equation, base 10. And then what do these two numbers do, essentially? They switch sides of the equal symbol, right? The 6 goes to the right, the 1 million goes to the left. So here is your exponential equation turned into your logarithmic equation. Same thing on number 18. 9 to the 1/2 power equals 3. Change it to logarithmic. So log, what's your base? 9. These two switch sides of the equal sign. So 3 equals 1/2. Same thing on 19. E to the 4 equals R. Okay, so these are just getting you used to converting from logarithmic to exponential. From exponential to logarithmic. So log, what's your base? E. These switch sides of the equal symbol, so the R comes here, equals 4. Number 20. R to the D equals 3. Again, log, what's your base? The base of your exponential part is the R. These switch sides, so you're going to have 3 equals D. Number 20, same thing. Number 20. Number 21. So now it's going to say convert. So it's going to give me the log base 5, 25. And it just wants me to convert this into an exponential equation, which we've actually kind of already been doing when we were finding logarithms. We were kind of turning them into exponential equations in our head and then searching for the missing exponent. Well, I'm just going to write that out. If I want to write this as an exponent, I need, what is the base? The base is what you're going to start off with. The base, the same thing that's the base of your log is the base of your exponent. So my base is 5. 5 to, what's your exponent going to be? 5 to this power. So to the second power equals 25. Number 22, log 0.01 equals -2. I've got, if I'm going to write an exponential equation, I've got to have a base. If you don't see a base, if this word is log and you don't see a base down here, remember, it is automatically 10. So I need 10 to this exponent, so 10 to the -2 is going to be equal to this number, so 0.01. ln 20 equals 2.9957. And it wants me to write this as an exponential equation. Again, this time I don't see a base. This base was automatically 10 because it said log. What is it if it says ln though? What is that base? That means log base e of 20 equals 2.9957. So if I'm rewriting this as an exponential equation, what is the base? It is e to that exponent, so e to the 2.9957 is equal to what? 20. And then the last one of these, log base m of v equals -z. Again, you know, in order to convert this to an exponential equation, you don't have to know what the m stands for, the z stands for. You don't have to know what any of that stands for to be able to convert it from logarithmic to exponential. You've got log base m of capital V equals negative lowercase z. And the reason I'm saying capital and lowercase is because I'm pretty sure that MATLAB is going to be case sensitive on these, which means when they use capitals, you do too. So let's see, what's my base? M. M to what power? Negative lowercase z is equal to what? Capital V. Now, 25 through 30 is all calculator work. So let's see what I'm trying to do on 25 through 30. 25 says use a calculator to find the common logarithm, and it wants me to find log of 62. So this is going to give me a big long decimal, and it's going to want me to round it to 4 places. So again, you're just going straight to your calculator, hitting the log button. What am I finding the log of? 62. Hit enter. If I'm going to 4 decimal places, so 4 places after the decimal. 1, 2, 3, 4. So it wants me to stop there, but I just need to remind myself, do I need to round this 3 up to a 4 or not? Which means, is the number after the 3 5 or greater? Since it's a 9, that means I will round that 3 up to a 4. So 1.7924. Nothing different on number 26, right? You're just typing in log 94. And then rounding your decimal to 4 spaces. Look at 27 though. I do want to do that one. Log of negative 16. Log, and then in my parentheses, negative 1/6. Look what that gives me. An error message that says non-real answer, right? This right here says, that would say, what? So if I don't see a base, that means it's automatically 10. That's saying, what would I raise 10 to turn it into negative 16? I can't turn 10 into a negative by giving it any kind of exponent, right? If I'm giving a negative exponent, that's just telling me to flip the 10, right? That's what negative exponents do, is they flip the base. They don't turn the base negative, they flip the base. If this exponent is a fraction, it just turns the 10 into some kind of radical. I can't turn the 10 into a negative number by giving it any kind of special exponent. So that's why the answer does not exist. Okay, you're going to do the same kind of thing on number 28. Instead of using the log button, you'll just use your ln button. So you'll do ln 82, ln 607.5. Again, that's going to give you some kind of decimal answer. What is this one going to give you? That would say log base e to the negative 0.97. You're not ever going to be able to raise e to an exponent and turn it negative. So again, that's why that one will be the answer does not exist. Now, we talked about this earlier for people that don't have the log base button on their calculator. It says find the logarithm using the change of base formula. That is just what you would do if you didn't have the log base button on your calculator. If it says log base 8 of 10, I'm going to find it both ways. I would do the log base button. If I just typed that straight into my calculator without using the change of base formula, I could do that in my math feature, right? Math, down to log base, and then put the right number. So I need to put the 8 down in the base, L to the right, put a 10 in there, in your parentheses, hit enter, and it gives you your answer that you would round to 4 decimal places. The problem says find the logarithm using the change of base formula. All the change of base formula means is the log of base 8, so log, just type it in, log 8, divided by, oh, no, sorry, wrong order. Log of this number divided by log of the base. Okay, so again, if I didn't have the log base feature and I just had a log button, I would do log 10 close divided by log 8 close. And you'll notice you get the same exact answer. Okay, you're going to do the same exact thing on 32, 33, and 34. You can either use the log base feature in your math function of your calculator, or do log of 15 divided by log of 6, log of 13 divided by log of 8, log of 12 divided by log of 500. It's all going to give you the same thing. Now, number 35 says to graph both functions in the same set of axes. So One is an exponential function, and one is a logarithmic function. Instead of saying f of x, I'm going to call them both y's. I'm going to call both of these right here. That means y equals 2 to the x. This just means this is going to be the inverse of that. F to the negative 1 of x. This means it's going to be the inverse of f of x. I'm going to put these two things in my y equals. So y equals 2 to the x. And the other one is y equals log base 2 of x. So let's look. Go to your y equals, clear it out. The first thing I'm going to type in is 2 to the x power. So 2, then go up in your exponent with this little up arrow and put that x up in your exponent. So that's going to give me an exponential function that should go right along the x-axis, cross the y, and then shoot up. Let's see what the inverse of this. So log base 2. So again, log base, I'm going to go to math, down to log base. So log base 2, and then put an x in my parentheses. So it's going to graph both of these things on the same graph. So let's hit graph. There's your exponential function. There's your logarithmic function. So just like we talked about at the very beginning of class over there, they are inverses of each other. They are symmetrical along. If there was a line drawn right down the middle of that going through the origin, they would be symmetrical along it, right? This one is your exponential function, y equals 2 to the x. And that one is your logarithmic function, y equals log base 2 of x. Okay, that is 9.4. So we'll do 9.5 Wednesday, 9.6 Friday.